Google builds their code using an internal tool called Blaze. In 2015, they reworked and outsourced a big part of it under the name Bazel. So let's have a look at Bazel today and build some C++ code. Hi, Zen here and welcome to my channel. So this is the website of Bazel. It offers a lot of features, but what we are today interested in is in getting started or in using Bazel. So here you will find anything that you need to know how to set it up. Because we are interested here in C++, we will follow some of the steps of the C++ tutorial here on their page. The first thing that we need to do this is to install Bazel on our system. In order to do that, what we need to do is to first install a second tool, which is called npm. So this is then afterwards used to install Bazel in the recommended way. So let's get npm. So we use our package manager apt-get to install npm. And we are asked for the sudo password. So here npm is already installed on my system. So I just did that in case you didn't have it. And then we will use npm to download Google's Bazel via their official or recommended way, let's say. So we will type in something like this, npm install -g from Bazel, and the tool what we need is the bazelrc. So this is what Google calls it. So let's run this, but let's put a sudo in front first because it also needs to write to the system. So here Bazel is being installed, and now what you can do additionally is to type something like Bazel --help, because if you run Bazel for the first time, it will then download some dependencies or some backends that it still needs to work properly. So the next thing that we need to do is to create the files that Bazel expects from our build. These are mainly two files at the beginning. These are the minimum two files that you need to get a Bazel build running. And this is the workspace file and the build file, both in all caps. And the workspace file actually is completely empty. The workspace file is used in Bazel to distinguish between packages. So everything that has a workspace file at the top level is considered by Bazel like a package and can be used to reference or to being referenced by other packages later on to build up some better dependency trees and better separation of the source code. The second file that you need is the build file, and this is where you need to put your instructions on how to build your code and what are the files that you want to put in. So for instance, here we want to create a binary, and this binary will be called main, and it will consist of the sources main.cpp. And the main.cpp here in this case is just outputting a small little string. If we want to build this now, we can go back to our console, and you see I'm already in the correct directory, and I just say Bazel build, and then I say main because I have named my binary main, and the target that I want to build in Bazel now is also called main. So here we see that it's analyzing the things that needs to be done, and then it's doing something in the background. And the interesting thing is that because I did this before, it didn't even compile something, it just fetched it out of the cache. But anyways, we now have our output directories here, and we see we get 4 output directories: bin, out, simple, and test logs. And I think test logs is empty because I don't have any tests here. The simple is basically, I think this can be then included by other packages that depend on this, so it's called simple because my folder here is called simple. The output is some data that I actually have no idea about it, so it's just some intermediate files. And in the bin files you find the actual result of your build, the main. So we can just run this by using here the command Bazel bin. So we go to this folder and run the main file, and here we see we also get the expected output. But Bazel has a little bit more to offer than just that. Using Bazel you can also see the dependency trees, so every dependencies that you have in your file. by using this command. So you can query, and you can query the target main for its outputs. So I think I need to remove these two slashes here. And here we now directly get the directed graph and can see that the target main itself depends on main.cpp and nothing else. This is also what we would expect. However, this is quite ugly, and Google has already optimized it in a way that you can show this also in a graphical way, which is much better. You need to install for this Graphviz and Xdot. I think these are the two common plotting tools for directed graphs. So what we need to do is sudo apt-get install Graphviz and Xdot. Graphviz and Xdot. And you also see I have already installed them. This was basically just for you. And now what we need to do is to use the same command that we did here, which is outputting us here this nice text, and pipe it into our Xdot. So we can just use Xdot pipe command for that and use these two exclamation marks. The two exclamation marks, they just repeat the command that I have already written here on the top, so I don't need to write it here anymore. And then it will create me here my dependency graph that main is depending on main.cpp. So obviously this is now not really interesting in this case, but if you have bigger projects, it can become very handy to have this in a graphical fashion. Then let's switch to our more complex example. So we switch to the complex folder, and we also have a look here. I have already prepared a little bit here. The workspace file is again completely empty, but the build file contains a little bit more. And here we have a main file which has dependencies to a line and a shape, and both of them has associated header files. And now we basically have two options, or several options, that I want to show you how to define this. So the first one would be that we type in all of the sources manually, where we have main, line, shape, and the header files. Or what we also can do, we can use the internal glob functionality of Bazel, which offers us the possibility that we can specify it should use all of the CPP files and all of the header files that are available, and use them in this project or target called main. So we can build this again using the Bazel command by using Bazel build, and the target is again called main. And then we use this, and here we see that we already get a little bit more output. That's because there are some error flags already introduced by Bazel, which are on per default, but usually not if you compile the code by hand. So there's some warnings that I get here for this particular part of code. But after all, everything works out nicely. If we now draw the dependency graph for that by using this command, again using the Xdot, we see that main depends now on 5 different files, on CPP, shape, line, and line. And this is now a better representation of the functionalities of that. So if we want to now switch the compiler to a different compiler, we have the options to also use the environment variable for that. So I think this is quite normal for most of the build systems, where you can just type in something like cc clang, and then it will use the clang chain to build the code. And we will see this in this case because then probably the error messages will look a little bit different than before. And here we see it looks a little bit different than before. Here it was using a different compiler, and now I chose the Clang compiler to build my program using Clang. Now, if you want to pass something along with your build, or pass some options like some compile flags and so on with your complete build, one option to do that is to use the bazelrc file. So this is a build configuration file that is affecting everything that is inside this particular workspace. That's also why you have these workspace separators. You can also have this on your user level or even on PC level, but it's not recommended to do so. And actually, I would also not recommend using bazelrc in professional builds, because yeah, there is a different way on doing things that you should then use. But for local builds, for small projects, this is absolutely fine, and I would use it myself anyways. So what we can do here is that we can specify for certain Bazel commands how they should be executed. For instance, we can say that if we use Bazel build, it should always append this cxx opt and append that it uses the standard of C++14. Or we can use this, and if we have several lines of these, they all get appended to each other. So it will append each of these two options to the compile command. Or we can also use the define and pass some defines to our code. And you can see this by building again using Clang and using Bazel, and it basically does the same thing and creates us a nice result, nicely compiled, and we have passed some flags. Now, if you want to dive into bigger projects and use Bazel for bigger projects, one of the biggest strengths of Bazel is reproducibility. So it will always keep your builds clean and in a very good state. But to do so, you need to set up your build a little bit differently. So you should not use the bazelrc file for that, but you should use so-called cross tools for that. So there's the possibility to define some tool pipelines and clearly define which compilers to use, which options to use, which compile flags to use, and so on. But to define those pipelines takes a little bit more effort than what I wanted to show you today. So it's not necessary for the smaller builds. But yeah, if you want to, I can make a video about the pipelines later on. But for today, I think we're settled. If you liked it, please hit subscribe and enjoy coding.